right, let's do some practice for our second objective of the Newton's first and second law unit. Remember, as always, let me read the question, then pause the video while you think of your answer, unpause to see how you did. What is the proportionality constant between an object and its acceleration by a given force? Actually, this should be in the next objective, so this will not be on your quiz. It's yellow mass, but don't worry, this one is misplaced. A ladder is balanced against a wall without moving. What must be true about this ladder? Press pause while you think about it. All right, so this is the key, not moving. When something's not moving, it still has energy. It has gravitational potential energy, so that's not it. Normal force, well, normal force is going up opposite of gravity, so it would still have that. Nothing is frictionless on Earth. So it experiences no net force. Remember, no net force means balanced, so nothing changes. Balanced and no net force mean the exact same thing. If an object is being subjected to two forces of equal magnitude or strength in opposite directions, here's what the free body diagram would look like. All right, so equal strength, opposite directions mean nothing changes. If it's resting, it'll stay at rest. If it's moving, it'll move at the same speed. So blue is correct. An orange rolls off a moving tray when the tray stops. Why is that? Remember, Newton's first law says object at rest stays at rest, object at motion stays in motion unless acted upon by an unbalanced force. So the tray is moving along, and when it stops, the orange wants to keep moving, so it rolls off. So that's Newton's first law, and another way of saying Newton's first law is this fancy word in the red, inertia. Objects want to keep doing what they're doing. In this case, the orange was moving, and it wants to keep moving. This is just like when you're driving in a car. Somebody slams on the brakes, your body wants to keep moving, and you jerk forward, and it's not very comfortable. Why doesn't the kinetic energy stay constant and a moving bike continue to coast forever? In other words, we said objects in motion stay in motion, so why doesn't it? Press pause to think of it. All right, well, anytime two things touch, like the tires and the ground, you have friction. And friction tries to stop stuff, so red and yellow seem really good. Friction causes energy to turn to matter in red or turn to heat. Remember what we've talked about in videos, rub your hands together real fast. Friction tries to slow them down, but it makes them hot, and that makes yellow our choice. Friction converts some of the energy to heat, so it can't go forever. An airplane is flying with a net force of 0. What's that tell us about the airplane? Press pause while you think. Remember, net force of 0 means no change. Slowing down, that's a change. Slowing down, that's a change. Constant speed, that's okay. Losing altitude means you're moving toward the ground. So constant speed means stays the same. Straight line stays the same. Green is correct. A ball on a cart keeps moving in the same direction at the same speed as the cart when it stops. Well, press pause while you think of the answer. If you were thinking law of inertia, you're right. Inertia would be correct. But remember, we said inertia and the first law of motion are the same thing. So inertia wasn't the choice, makes first law of motion correct. Newton's first law says an object in motion tends to, press pause. Just straight memory, objects in motion stay in motion, so green is correct. All right, you should be good for your second quiz on the Newton's first and second law unit.